little bit of Python, but there are, please note that there are innumerable books available free in net on Python. I can just give you some of the names, just one or two names which are you can download from Python for Informatics, Think Python, Python Crash Course, Byte of Python. Now this one is just for the beginners, but learning Python and Think Python, this is slightly better. This is considered a sort of a Bible in Python. The last one, Learning Python by Mark Luth, but it is freely downloadable from the net, PDF file. It's a huge book, mind you. The book consists, I think, of 1700 pages. So, even downloading itself is a story. The best, I did not use either of them, but you can still do a huge number of complicated things. Simple 3, 4, 5 lines. Okay. We'll try before the lunch will be say 1 more hour, so we can try. Now, machine learning using Python. Say, machine learning is here, Python is here. Unfortunately, I think this line on the point is that why should we use Python to learn machine learning? Where's the first person? And my answer, not as per book. My answer is very simple. Let me just write it down so that you can understand. Two reasons. Number one, Python is very easy to learn and write. Second, is it is a, I said that there is a host of built-in library which you can use, and we will learn today another library called scikit-learn. Now this is a library which is available freely for machine learning only. All algorithms of machine learning is there, which means you don't have to write any one of them. You only have to know how to use it, how to optimize it, how to play with some of the parameters maybe, and so on. Now, one other thing I missed out while I was discussing those buzzwords. I don't know how many of you are aware of things called open source and closed source. Closed source and open source, what is the basic difference? So, Windows is a closed because it is proprietary and owned by some company. Linux, on the other hand, say any distribution is open because Even you can see the source code, you can change if you want to, and so on. Now all those new technologies that I mentioned in the first half, just the beginning, they are all thankfully open source. So this entire whole thing which is available to you is open source. Another thing which nothing to do with this, but I wrote down, if you remember, 2-3 very interesting things called, say, data analytics, recommender system, sentiment analysis. Though I am not showing here, I'll maybe after lunch I'll just show you one program that in a small 6-7 line you can do a sentiment analysis program writing in Python, which is normally not possible in writing it in C or Java. Other also, say for example, there is a concept of map reduce, which I said is basically you build a lot of data and then map it, run it, and then reduce it to finally result. Now map and the reduce, they are actually two programs. Now if you write it in Java, it will at least be a 1 page each. Now if you write the two things in Python, it will be 4 lines each. So this is the kind of simplicity which helps you. But there is a drawback also to it. Let me also point out that since Python is per se interpreted in a way, it is not as fast as C. Now if you compare speed of a C program with Python, most of the time it will not match, number one. Number two, I mentioned certain libraries called NumPy and Panda and SkyPy. Now they internally use huge number of C code. So that's just to ensure that very big data handling, how to do it in C. So that way it is there. Okay. Now this scikit-learn is also a library which is freely available, and every time some more modifications, some more new versions are coming. So you have to see what is the latest. Now before moving into this, I will just only say that if you have a Linux machine, if you want to learn Python, the default Python, as I said, is 2.7, but somewhere if you say Python 3, 3.x will also be there. But the best way to do is to install a Anaconda distribution of Python. This is basically, you search in Google for Anaconda Python, and then it is a Continuum.io naam ke company hai, who gives you a entire Python package in a single file named I think it's called some Anaconda something version.sh, and since it's a sh file, you just say from the dollar prompt sh and then file name. It will install not only the Python but all its required, most of the commonly used external libraries together with all the dependencies. So it's a complete package installed in a single directory and available to you. So Anaconda distribution you can install. This is also available in Windows and also available for Mac. But Windows has some other peculiarities that is there. But you can run theoretically any Python program in Windows, Unix or Mac. Mac means Mac OS, the Apple products. Okay. We'll start machine learning and using Python, but just to give you some very basic idea about machine learning. What do you think of when I say machine learning? Any idea? And from the audience, you are supposed to say something.
Machine learning
How to?
Depending on the experience, machine learns to take the next output possible.
Okay, that is one definition. Yes. Something else? And what is the connection क्या है? Machine learning and artificial intelligence. Huh? Okay, I'll just put it in this way. You see, artificial intelligence, as sir correctly said, is a very old thing. 50s, 60s में था, 1950s, 1960s से start है. Machine learning is rather a relatively new topic. It's a subset of AI, number one. Number two, AI per se is only followed and done by most of the time by scientists or theoreticians doing some research work in something. So which is not in the domain of a normal industrial use. But the reason why machine learning has now become popular in the last maybe 5-7 years is because applications of machine learning are, we will know also what are those, has pervaded our common usage. So that's the reason why industry has now started, and a whole set of programmers have started investing their time and energy in trying to find out and do something on machine learning. And that's the reason why it has become spread so fast and so important. Okay, with this, let's see what basic machine learning is. Not that far off when this will come. What is machine learning? It is a type of AI that provides computers with the ability to learn without being explicitly programmed. Machine learning focuses on the development of computer programs that can change when exposed to new data. The process of machine learning is somewhat similar to that of data mining. Now, what is data mining? It's similar to machine learning. What is machine learning? Similar to data mining. Data mining is nothing but you interpret the data to get some meaning. Full stop. Simple. If I write down, get a very simple. Say, what is this? You don't know anything. It could be anything. Now, if I say these are the high and low temperatures of the last 3 days, say in Shillong, then you will try to get the meaning. Oh, okay. So that means high and low. So that means whenever you are reading a data and trying to apply a context and getting a meaning out of it, that is the whole purpose of computation. It's not only machine learning, computation. But what is difference? The machine learning is about extracting additional knowledge from data. It is a research field and which is at the intersection of statistics, AI and computer science, also known as predictive analytics or statistical learning. So there are so many similar names to machine learning. And it is again a research field, so that means every day, in fact, if you subscribe to some of the blogs or posts of ML, every day something new is coming. Someone else has written something which is slightly different than what perhaps he has written. That's all. So as per Wikipedia, it is the subfield of computer science that gives computers the ability to learn without being explicitly programmed. Evolved from the study of pattern recognition, evolved from the study of pattern recognition and computational theory in AI. Machine learning explored the study and construction of algorithms that can learn from and make predictions on data. Such algorithms overcome following strictly static programming instructions by making data-driven predictions of decisions through building a model from sample input. এই পুরো জিনিসটা একবার পড়ে কেউ মানে বলতে পারবে কি? What is the meaning out of this? থাকলে হবে না, একটু সে সামথিং এত বড় একটা ডেফিনিশন লেখা হয়েছে খেটে খুঁটে, তার থেকে তো কিছুটা মানে আছে। Based on? Okay, but something more?
Normally, we write the program today, which is very, the algorithm which we write, it is very static, means it is very hardwired. Means it cannot program, so it cannot adapt. But we need to write adaptive program.
Okay, right. Both are right. Anyone else?
So you have to make the code such that it can ability to learn itself and doing the changes, then it can also make the changes by itself.
How? Yeah, you're right. And all three are right. How?
By providing labels as right output or wrong output and re-adjusting things.
So there are
Okay. I mean, let me put it in this way. Normal programming, is that I write a code and then I give some input data, and depending on what I want to do, I get some output data. That's all. Now this code, as he correctly said, is fixed. Okay, this is a normal paradigm. We write every day this. Some data and then some output. Now what happens if I say that this code is not fixed, but depending on the input data, someone is changing the code so that it matches the output data. So that means initially I start with the code, with some data I try to derive the result and match with the output data. So this is say my data, this is some benchmark data. So I write this, try to match. If it is matching, great. If it is not, change this code a little bit, again do the same. Now, are you getting it? So someone, let us not say who now, someone is doing these operations till you get a almost match between these two. So when you are changing this code and arriving at some meaningful thing, that is meant by you are developing a model. Model means not that model of say Durga or Lakshmi, not like that. It's some code which now can operate on this input to get a data which matches the output data. Now normally what happens is it is changing. If it is done by human, then it is a normal paradigm. But if you write a program which can change itself, and that is called machine learning. Have you understood? Maybe in a very rudimentary way, but in my own way, I am trying to make it explain. So that means this code itself, please note, this code is written by humans only. But I have written it in such a way that this happens. Now, just before going into any further, let us try to give a rather simple, but really, I think, effective example of how you can do it. It is assume a very foolish thing that I have a set of numbers. and say the output is this. Now if you are only given some numbers and output, so what I will normally do, I will try to do some jugglery. Maybe I will write first of all maybe a code to compute the mean, a code to compute a median, maybe a code to compute say standard deviation or whatever. I mean some statistical thing. And each time I will try to see that with this code, if I write this code, am I arriving here? If yes, great. If not, try this one, try this one, try this one and so on. Let's assume that this one works. Assume. So now after running 3-4 types of program, I arrived that this one will work with this. Okay. Now I can also write down a program which does it mechanically or automatically. This is what ML is about. Basically it is based on a data. It is trying to optimize a function or a mathematical formula to arrive at the result. Now have you understood? So if this, say, if these are plotted, say some data like this, some data. So if I write a program to represent this data, the best option perhaps could be maybe some lines like this. Now, this line, which is nothing but an equation, now you have to arrive at this. Now, this is what ML is, and then the next part is that when I have data and after some iteration I arrive at this given data. Now if a new data set comes, can I use this algorithm to arrive as a result? I'll give you slightly different way of giving a meaning. Now ML is mostly used in predicting something. Let's say that a tumor in a human being can be cancerous. Now for cancerous, there is a set of data. For benign, there is a set of data. I apply a logic to find out the relationship that given a set of values, say here also let's say all has 3 values. So given a value, interpret from there and then try to find out whether that data is C or B. So that is the prediction. Before that I have to, of course. Now let me again say the same thing in a slightly different way. There is a reason why I am saying all these things. You will realize slightly later. Assume that I have a data. Now what I will do is this. I will split the data into a portion called train and a portion called test. With this train portion, I will develop a model to test out the result. So there is a result data also. Say, let's assume that there is a result data. Okay. Now, this model, after we train, we will apply the test part and see whether our model works good or not. If it is good, great. If it is not, then something is wrong with the model. So I have to change or choose a different model or a different way to do it. Now once I do this iteration a number of times and find out which model, how this will work, now I can have a totally new data and predict whether this is in line with the previous one or not. Now imagine that this was cancerous, this was benign, this was benign, this was cancerous, this was cancerous, this was benign. So these are the data where I have trained the model to find out whether the tumor is cancer or benign. Test it out that if your model, I give this new data, still whether it is coming C or D correctly or not. If it is great, if it is coming, great. If it is not, my model is wrong. So I have to do something more. Now if I see that all this is coming correct, then with a new set of data, the question is whether I can predict C or D. This is the whole essence of ML. Now if you have understood my last 15 minutes of whatever I have said, you have understood what ML is. I'll give you a minute there. Think about it and try to question if you have not understood. Do you think some meaning is coming to you? Construction of algorithm that can learn from and make predictions on data. Such algorithms overcome strictly static programming instructions by making data-driven predictions or decisions through building a model from sample input. Sample input is this. Okay, let's assume you have understood. Where it is used? Now it is now used almost in everyday life. From automatic recommendations of which movies to watch, what food to order, which products to buy, online radio, recognizing your friend in your photos. Many modern websites and devices have machine learning algorithm at their core. How many of you have used Siri of iPhone? Or in fact nowadays Google Assistant? Maybe these are very high-end things. But recommender systems, everybody has used it. Now recommender system, I said that you can write it in Python, yes. But recommender systems can be written in two ways. One, the classical way. And the second is, I don't know how many of you have noticed, in the last, let's say 5 years, how many Google search each one of you has done? 1,000 lakhs. Have you noticed that, suppose AI, I am searching every day and he is also searching every day. Now he is traversing some page, I am traversing some page. After some months, Google will give a different result to AI to me than to him. This is very interesting. The same AI topic. How did it changes? Because it is trying to follow a pattern. Which are the topics I am looking into? Which are the topics he is looking into? And further training the model so that the search engine result gives you slightly customized result to me and to him. Have you understood? So what is the daily usage? I mean, if you say, so when you look at complex websites like Facebook, Amazon or Netflix, it is very likely that every part of website that you are looking contains multiple machine learning models. Outside of commercial application, machine has a tremendous influence on the way data-driven research is done. ML is applied to diverse scientific things, finding distant parent, analyzing DNA sequence, providing personalized cancer treatments. So, the basic sense is that now every moment ML is being used for everyday use. Okay. Why ML? Earlier intelligent applications implied hand-coded rules and if-else then decision. This is what the classical is. You read a set of data and then interpret and give some result. That's the standard thing. Think of a spam filter instead. Now, what are you doing? A spam filter. Let us see spam filter how it works, and then you will also get another glimpse of how ML works. How do you think a spam filter works? Any idea? Hey, you are all from IT.
Linkable marks, some messages is spam. So
No, basic you the mark correctly. Then how would you identify a spam?
it's in spam folder.
Hmm?
Some other people
It's in the spam folder of the Gmail.
এই তুমি মানে তোমার মন কোথাও আছে তুমি কথা বলতে পারছো first time when I'm opening an account and a mail comes, how does the program knows whether it is spam or not? I have not marked anything. এবার বলো
but some just training.
আবার ট্রেনিং দূরে চলে যাচ্ছে সিম্পল ভাবো
Sir, other people may have marked the same website as spam.
এছাড়া
Some content in the email is the blacklisted or something.
you see the first time there may be some keywords or reserved words which make it spam. হতে পারে $1 million lottery. Everybody knows $1 million lottery money for a spam. So that is one way to categorize. So there may be a set of words initially. There is a set of maybe some words which you are checking and then marking. This is the first time. But as you go ahead, I will additionally mark some mail as spam. Now comes the question of learning. You see, now next time what it will do is this. Apart from this spam marked whole thing will also be analyzed and added together. So this is learning. Because every day you are saying this is spam, this is not spam. Sometimes false positive and false negative also happens. Get a spam jawar kotha na chole geche spam. So you are doing what? No, this is not spam. So it comes back to inbox. So then it learns, okay, eita tale spam noy. Okay, so this is how a spam filter normal. This is the normal, and learning is the second part. So, however, using hand-coded rules to make decisions has two major disadvantages. The logic required to make a decision is specific to a single domain and task. Changing the task even slightly require a rewrite of the whole system. Obviously, আমি যদি এটা হ্যান্ড রিটেন করতাম তাহলে কি করতে হতো এই প্রোগ্রামটা আমাকে সারাক্ষণ চেঞ্জ করতে হতো somebody would have been imagine now that 1 million people is writing and receiving mail and marking spam differently because what is spam to you may not be spam to me. So the program then handwritten যদি হতো 1 million type of logic if then else করে লিখতে হতো would have been impossible. Secondly, designing rules require deep understanding of how a decision should be made by a human expert. So human expert আমি সারাক্ষণ পাবো কোথায়? How to do it? Okay, so this is why machine learning. Okay. Another one example of where this hand-coded approach will fail is in detecting faces in images. Ajikal image detection in faces, Facebook if you know your friends, they will pick up all correctly. How do they do it? It's not done through normal method. Let me tell you. Every smartphone can now detect a face in an image and was unsolved problem until 2001. তার আগে একটা ক্লাসিক্যাল মেথডে করতো বিটে ভেঙে নিয়ে ওই যেমন ভাবে ফিঙ্গারপ্রিন্ট প্যাটার্ন analysis করে, almost something like that. That was a very incorrect way of doing it. Now, of course, what they do is they do basically a sort of decision making based on AI. We'll explain also a little bit of it. Main problem was that in which the pixels in that perceived by computer is very different from how human perceive of images of faces, enough for an algorithm to determine what characteristics are needed to identify a face. Not only a face, but anything almost nowadays. So this is okay. This is some more definition. Another way to define is the science and engineering of making intelligent machines, especially intelligent computer programs. It is related to similar task of using computers to understand human intelligence, but AI does not have to confine itself to methods that are biologically observable. So AI and ML, though it is a somewhat similar, but please note that AI is much broader in sense. ML is, you can think of a subsection of AI which is used in a daily normal usage of human beings. So AI is just only scientists and AI, fine, someday it will happen. What is the difference? Both these hardware are very hot now and sometimes used internally downloadable, absolute, to me, Urdu mathematics book on statistics, and it's considered as the Bible. So there everything, whatever mathematics of these are edited. If you want, you can read it. When to use? Now, if you have a moderate or a large training data set, if the instances have several attributes, attributes is features. Okay, features and attributes are the same. Given the classification parameter, attributes which describes the instance should be conditionally independent. Application typical sentiment analysis. I said what sentiment analysis is. Okay, document categorization. Google uses this to do what is called page ranking. I don't know whether some of you have heard of the word page ranking. Google search a result that is based on some page ranking which they have already done, and that is given back to you. It also used for classifying news articles about technology, internet, and email. So these are common applications of Nair-Bayes type of classifier. Please note that this is not the only algorithm used for this. There can be others also. This is one of them. Advantages: it performs well when input variables are categorical. Categorical means they are quite independent to each other. A Nair-Bayes classifier converges faster, requiring relatively little training data, and with this classifier algorithm, it is easier to predict class of the test dataset. Though it requires conditional independence, classifier has presented good performance in various domains. So these are some of the advantages. Another is, this is a different algorithm called K-means clustering. It is a popular unsupervised machine learning algorithm. K-means is a non-deterministic and iterative method. Algorithm operates on a given data set through predefined number of clusters called K. The output of K-means algorithm is K clusters with input data partitioned among the clusters. So that means if I want to categorize a cluster, a set of unknown data, I can use this logic, this algorithm to do it. Now K is maybe 5, maybe 10, whatever. Say, for instance, let's consider K-means clustering for Wikipedia search results. The search term Jaguar, if I search in Wikipedia, it will return all pages containing Jaguar which can refer to Jaguar as a car, as a macOS version, and as an animal. Now, Jaguar is used in 3 contexts. Now, what it will do is this, it will also cluster all animal related to a part, car, jaguar to another category, macOS jaguar to another. So that means though it perhaps say returns 300 pages, it will try to cluster them into 3 groups. That is what this algorithm does. So it can be applied to group the web pages that talk about similar concepts. So the key is similar concept. So that is what it says. Advantages: in case of globular clusters, K-means produces tighter clusters than hierarchical. There is another version called hierarchical clustering which we will not discuss. But compared to that, it can do better. Given a smaller value of K, K-means clustering computes faster than hierarchical. K can be 1, 2, 10, 100 and so on. So for smaller values, it gives a better result. That's all it says. Application: most search engines like Yahoo, Google cluster web pages by similarity and identify the relevance rate of search result. So this is where you normally apply this sort of an algorithm. Support vector machine. Now this is a really, some of these concepts are really old. Support vector machine is one of them. It is a supervised machine learning algorithm for classification or regression problem, where the dataset teaches SVM about the classes so that SVM can classify any new data. It works by classifying the data into different classes by finding a line or a hyperplane which separates the training data set into different classes. As there are many such linear hyperplanes, SVM algorithm tries to maximize the distance between the various classes that are involved, and this is referred to as margin maximization. If that line maximizes the distance between the classes is identified, the probability to generalize well to unseen data is increased. Now, support vector machine really conceptually to understand really requires a huge discussion which I am skipping. But just for the sake of you, there is a lot of web pages dedicated on support vector with examples. So you can better, if you really want to understand, take the example one and then try to follow. That will be better rather than trying to understand the underlying math or stand of it. They are also classed into 2 categories, linear and non-linear. We'll forget that. Advantages, let us see. Offers best classification performance on training data, renders more efficiency for correct classification. Best thing about SVM is that it does not make any strong assumptions on data and it does not overfit the data. Overfitting is something which we will discuss later, but there is something called overfitting. Applications are commonly for stock market forecasting. It can compare the relative performance of a stock when compared to performance of other stocks in the same sector. Now, don't think, again, I warn you that if I can really do this, I can tomorrow predict the price of TCS or Google or Reliance and then buy those shares accordingly. Don't do that unless you want to really lose money. But this is one way to do that. Relative comparison of stock helps manage investment making decision based on classifications based by SVM. Now there is another algorithm. Now this is very commonly used called Apriori machine learning. It is an unsupervised machine learning algorithm that generates association rules given a data set. Association rules itself is a separate topic of discussion, but this is very common in that sense. Association rule implies that if an item A occurs, then item B also occurs with the probability. Most of the association rules are generated in the if-then format. Example, then you will see, if people buy an iPad, then most likely they will also buy an iPad case. So now you can understand where you can use it. So that means if I can try to search the data and then try to categorize it. That if someone has purchased an iPad, he will also purchase maybe a case or an adapter or a power adapter, that sort of thing. So, association rules. So this way a ratio is derived out of, say, 100 people who purchased an iPad. 85 people will also perhaps purchase an iPad case. So basic principle on which this works is, if an item set occurs frequently, then all subset of the item set also occur frequently. Infrequently, then that is again the same thing, say in a different way. So association rule is a very common thing, particularly in e-commerce website. Somebody purchases a shirt, then most likely he will also perhaps purchase a jeans trouser, that sort of thing. If there is, may or may not, but this is just some association rule. Advantages: it is easy to implement and can be parallelized easily. What is this mean? Hey, তোমাদের ফোনে এই 2 কোর 4 কোর 6 কোর 8 কোর বলে বিজ্ঞাপন করে। What does this mean? কেউ ভেবেছে কখন? Your smartphone এই বিজ্ঞাপন করে না? Dual core, 8 core, 6 core. What does this mean? মানে প্যারালাল লার্নিং প্রোগ্রাম জিনিসটাই কি আছে? What is the CPU 8 core means?
All the cores can work independently.
Huh?
All the cores can work independently.
But what is a core?
Yes.
What is a CPU and what is a core? একদম সেই ওই অবজেক্টের ক্লাসের মতো। এত ডিফারেন্ট হওয়ার কথা না। আগে কি ছিল? CPU is one where all the processing was done. Later on, what they wanted to do is, bringing the CPU one, they wanted to divide or subdivide this. So one CPU, but 4 core means 4. You can think of as if there are 4 CPUs working independent to each other also perhaps, or sharing some data and doing the job parallelly. So this is the quanta of core. So as the number of cores are more, you can have better parallelization if your program is written like this. Please note, normal program, একটা কোর না দুটো কোর না ছটা করে যায় আছে। Normal Java program, normal C program, you are not writing per se keeping core in mind. Core keeping in mind করে লিখতে গেলে কি লিখতে হবে? Thread. How many have written programs in thread? হাত ওঠাও। চালিয়ে দেখেছো কখনো একটা সিঙ্গেল কোর আর 4টে করে তফাৎ হয় কিনা? লিখেছি তো ভালো কথা, মানে লিখে কিছু হয়েছে? ইয়েস যে বলেছে না, তাকে আমি জিজ্ঞেস করবো কালকে এনে দেখা। ওকে, disadvantage হচ্ছে sometimes apriori algorithm can be very slow. কেন? The association rules, if it is a very longish one, A তাহলে B তাহলে C কিন্তু D নয়, মানে if that sort of rule, if it is really big, then computation becomes very slow. Number one. In a database scenario, it assumes transactions are memory distinct. Database কয়জন ভালো করে কাজ করেছে? আপনি জানতে চাই কজন ভালো করে কে এখানে কোন ডেটাবেস পড়ানো হয়? ওরাকল না এসকিউএল। এসকিউএল কি একটা ডেটাবেস না? ল্যাঙ্গুয়েজ। কোনায় চলে যাও দেয়ালে। এসকিউএল হচ্ছে একটা ল্যাঙ্গুয়েজ। ডেটাবেসের নাম কি? Suppose Oracle. Or have you used any other? MySQL. Okay. MySQL is a free, Oracle is a price product. So open source and closed source is better. The database transaction, memory resident for and money. What is the meaning of this one? এবার এখন আমি transactions কি সেটা বলবো? সেটা না। What is a transaction? One logical unit of work in a database. It could be maybe one insert, or multiple insert, or multiple update. আমি যেখানে বলছি begin trend end trend মাঝে অনেকগুলো আছে লাইন, that is one unit. Now when it finishes, it normally is not resides in the memory. So হয়ে গেল কাজ, it is then flushed to the database. কেন? Now transaction এর এন্ডে কি থাকে লেখা normally commit. So commit মানে ও database এ লিখে ফেলেছে, তার মানে মেমোরিতে নেই। কিন্তু ও বলছে এখানে in a database scenario it assumes transactions are memory resident. So that means I have to write something special to keep all the transactions in memory, which is a disadvantage. Normally no database by default does it. Once a commit is there means everything gets roughed up from the memory. Anyway, requires many database scan. Many database scan difficulty to keep, they are all disk based. So that means time consuming. Memory and disk konta basic obvious. Okay, but partitioning can be used to improve efficiency. So this is for a priori machine learning plus minus is our application. Detecting adverse drug reactions, market basket analysis. Many e-commerce giants like Amazon use Apriori to draw insights on which products are likely to be purchased together and which are most responsive to promotion. I don't know how many of you have noticed. I'm trying to look, say, let's say for a speaker. They will also show me similar speaker is one, but also show me speaker stand, maybe some other adapters to speakers and so on. So that means things which are purchased together. Okay. And another is autocomplete applications. Google autocomplete, have you seen? Whenever I am typing in a query, it tries to autocomplete my search. Okay, now autocomplete is another popular application wherein the user types a word, the search engine looks for associated words that people usually type after. So, I mean, machine bollam or learning likhte chesta korlo ba hoyto bhulo likhte pare, but normally it tries to, after some time, it tries to guess the correct. So these are some of the applications. Another is which is called linear regression. Linear regression shows the relationship between two variables and how the change in one variable impacts the other. The algorithm shows the impact of dependent variable on changing the independent variable. Independent variables are referred as explanatory variables. Dependent variable is often referred to as factor of interest or predictor. Advantage is it is one of the most interpretable machine language common learning algorithm. It is easy to use. It is mostly used in machine learning techniques that run fast. Typical application that is estimating sales. Estimating sales in an e-commerce website or any website is a very important thing. You can try to estimate that. So there linear regression is used for sales forecasting based on a trend. At a particular sunglass could be clear. So trend theke I'm trying to predict the sales and stocking properly. Risk assessment. This is normally done in insurance and financial. A health insurance company does a linear regression analysis on number of claims per customer against age. A huge gap. Insurance industry te, have you ever thought je ei je একটা প্রিমিয়াম ক্যালকুলেট করে কি করে করে এবং most likely তোমার প্রিমিয়াম ক্যালকুলেট আর core premium calculate will be slightly different. Assuming both are same age, both have same something, but still it will be different. Why? না ক্লেম তো ওরা দুজনেই করে প্রথম টাইম ফার্স্ট টাইম। Okay, so there's a huge calculation behind it, not this only, but risk assessment not done through email. আগে ওরা ম্যানুয়ালি করতো, এখন হয়তো এমএল কেউ কোনো কোম্পানি ইউজ করে, মেবি। I'm not sure about any Indian company does it, but I know how they do it, and that's a huge thing. This analysis helps insurance companies find that older customers tend to pay More insurance claims, such analysis results play a vital role in important business decisions. So, accounting for risk. Obviously, there are boys who they will make more claims than young generation. That is true. Decision tree machine learning. These are separate parts. So let's take an example. Decision tree is a common algorithm. So let's take an example. Suppose you are making a weekend plan to visit a restaurant in town as your parents are visiting. Whenever you want to visit a restaurant, you ask your friend if he thinks you will like a particular place. To answer your question, your friend first has to find out the kind of restaurants that you like. You give him a list of restaurants that you have visited and tell him whether you like each restaurant or not, which is a level training. When you ask your friend whether he will now like a particular restaurant R or not, he asks various questions like, is R a rooftop? Does a restaurant R serve Italian cuisine and so on? So that means, based on your previous labeled structure, your friend is making a decision on your behalf. So it's basically a decision tree. Normally, on a decision tree, you know, restaurant then is it a veg or non-veg? Non-veg, okay. Non-veg, is it Italian or Mongolian? I mean, go on doing that sort of decision tree. So that is what decision tree is all about. So your friend here is acting like a decision tree for your favorite restaurant. It is a graphical representation that makes use of branching method to exemplify all possible outcome of decision based on certain conditions. আমি একটা tree আঁকতে আঁকতে যাচ্ছি, basically a complicated tree. So in a decision tree, the internal node represents a test on the attribute. Each branch of the tree represents the outcome of the test, and the leaf node represents a particular class name. Italian, বা non-veg, বা এখানে ভালো salad পাওয়া যায়, or এখানে ভালো dessert পাওয়া যায়. That sort of leaf is the last. Classification rules are represented through path from the root to the leaf node. মানে আমি প্রথম থেকে শুরু করে veg, non-veg এরকম করতে 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 একটা জায়গায় গিয়ে. That is the classification rule. Types, they are called, two types of decision trees are there. One is called classification tree, another is called regression tree. These are considered as the default kind of decision. And regression is when response or target variable is continuous or numerical. Regression is used. These are generally used mainly predictive kind of problem when compared to classification. এটাও একটা ক্লাসিফিকেশন আছে, কিন্তু দেখা যায় যে why should you use these machine learning algorithms help make decision under uncertainty and help you improve communication as they represent a visual presentation of decision. Decision tree machine algorithm help a data scientist capture the idea if a different decision was taken, then how the operational nature of situation or model would have been changed in sense. Okay, কোথায় use করবে, when to use, I'm not reading it out, it is clear. Decision trees are best suited when the target function is discrete outcome. Advantages: decision trees are very instinctual and can be explained to anyone with use. People can be even a non-technical background but can decipher the hypothesis. When using decision tree, data type is not a constant, as they can both handle categorical and numerical value. Numerical values মানে 4 5 6, categorical মানে veg, non-veg, okay, dessert, non-dessert, that sort of. Decision tree learning algorithms do not require any assumption on linearity. These algorithms are useful in data exploration, save data preparation time and so on. So these are some of the advantages you can go through it later on. There are drawbacks also. The more number of decisions is in a tree, less is the accuracy of any expected outcome. Number one. Major drawback is outcome may be based on expectations when decisions are made